Hello students, welcome back. Section 4 is about circles. How important is this? Well, for trigonometry, the circle centered at the origin is very, very important. Other circles are not very important. Now, do we need some analytical geometry, which will be covered in pre-calculus? If you're going to become math teacher track, the high school math teacher track 4 through 12, then the analytic geometry, conic sections, those are going to be important. So make appropriate decision based upon what you major in. I'll cover everything here, nothing else. Here's the standard form. A circle of radius r centered at h, k. Let's see, do we have a visualization? Yeah, h, k is here, and arbitrary x, y in the circle is there. What's the distance between these two? That's the radius r, and distance square is square root square, so you end up with this formula here. Square root of this is actually the distance formula, and taking the square of both sides. That's how you get this Pythagorean thingies. In a special case, when h and k are both zeros, then you're going to get a circle centered at the origin. And in general, you have this. Circle centered at the origin with radius r. But among those, the most important is the radius is also 1, which we call the unit circle. X squared plus y squared is equal to 1, like this. But in general, x squared plus y squared is some r squared. From here, if I break up all the complete square and do some simplification, you're going to end up with some expression like this. X squared plus y squared plus ax plus by plus c equal to 0 form. I can put right inside this 0 and then move everything to the left hand side. So as somebody do all this and equal to something, or plus c equal to 0, they don't mean anything. And if a and b are some rational numbers with dirty denominators, then instead of dealing with all those denominators, take the common denominator and multiply all and then kill off all the denominators. In that case, we have this x squared and y squared will become a little bit tougher, and we have capital A coming out like that. Both are considered as general forms. And the deviation is here, as a matter of fact. You see, break up this complete square, 2hx and 2ky, and then rename this 2h as a and 2k as b, and then take everything as h squared plus k squared minus r squared as c, then you're going to get this form. So a is negative 2h, b is negative 2k, and then c is this. And if you want to find out the center and the radius of the circle given in the general form, well, you can use this formula. H is negative a over 2, k is negative b over 2, and r squared is 1/4 a squared plus b squared minus 4c. How useful is this? I don't know. If you're comfortable with the formula method, go ahead and use it. Personally, I don't like it very much. Here's an example problem. Find the standard equation of the circle centered at negative 2, 1 that runs through the point 3, 2. Okay, centered at negative 2, 1, so x plus 2 squared plus y minus 1 squared, equals to r squared That's what we are looking for. Is that clear? Circle centered here. Now, how do you find the radius? Well, distance between the center and this point is going to be the radius, isn't it? So r squared is coming from the distance formula, -2 minus 3 squared, and the difference of y coordinate, 1 minus 2 squared. And what is this? 5 squared, so 25, and then plus 1, 26. So it looks like the answer is like this. Does it look okay? Or would you prefer to use the formula method? I don't think anybody chose formula method. From the standard form, we got the center, -2 and +1. The formula here, standard form, comes with negative, so we need appropriate sign change. And then we find out the radius by taking a distance between these 2 points. Let's see, do we have... Yeah, okay, alright, that's done. Do we have a picture? Well, -2, 1 and 1, 2 here. Okay, alright. And visualizing this kind of picture using Desmos graphing calculator, I'll leave that to you. Oh, before erasing anything, find all intercepts of the circle of the previous problem. Let's see. Intercept, we have 1, 2, 3, 4 of them. How do you find those out? Well, the same idea. Plug in x is 0 and look for y. Plug in y is 0 and look for x. So if you want x-intercept, then plug in y equal to 0 and look for x. Excuse me, plus 1 equals to 26. Is that right? Okay, alright, I'm looking for x, right? Break up this parenthesis and then refactoring, that's crazy. It's gonna be a lot better to take the square root right here. Square root of 25 is 5, so x plus 2 is either 5 or x plus 2 is -5. So we are getting x is 3 or x is -7. So x is 3 or x is -7. If you like the coordinate expression, 3, 0 and -7, 0, those are the x-intercepts. Let's go back to the picture. -7, 0, 3, 0, it looks like it. If you use Desmos graphing calculator, even more will be revealed. Okay, how about y-intercept? Substituting x equal to 0 and solving for y, I'll leave that to you. So what do you get? Yeah, this is already done. Next, put x is 0 and solve for y. So 0 plus 2 squared is 4. Flip it over, x minus 1 squared is 22. So y minus 1 is plus or minus square root of 22. Okay, flip 1 to the other side. 1 plus or minus square root of 22. 1 plus square root of 22, 1 minus square root of 22. Right here, 1 plus square root of 22, 1 minus square root of 22. Those are precise solutions, and the precise solutions are always more desirable, but if you use decimal expressions here, with all the work, and in the end, if you use decimal expression, you're going to get full credit. But just decimal expression and then no work like this, then depending upon other things, maybe 3 points off, 4 points off, maybe 5 points off. Let's see, how about the next example problem? Find the center and the radius of the given circle. Okay, alright. Okay, alright. That's why I kept this formula method open. You're going to use this h and this k, sorry about that. This k and this r formula. Would you like to use that? If you ask me, no, I don't want to use that. I'll do it this way. Okay, alright. And then let's make some complete square out of it. X squared minus 2x y squared plus y equals to 1. Okay, how do I make a complete square out of this? The first one is easy. Let me copy and paste. First one is easy. If you add 1 and then add 1, this is complete square. X minus 1 total quantity squared. That's going to be good. Alright, this one here, highlighting in blue, and this one here, highlighting in blue. Okay? Now this one is going to be trickier. What do I have to add here to make this into a complete square? Any idea? The answer is 1/4. Ooh, how to get 1/4? Well, the complete square includes 2 and then k, and this one has to be k squared, and this 2k will have to become 1. So this k has to be, as a matter of fact, 1/2, and here I'm gonna need 1/2 squared. That results in 1/4 here. Let me go back and highlight this in red. Why am I not getting what I want? Okay, alright. And this one here. So x minus 1 total quantity squared plus y plus 1/2 total quantity squared is 1 plus 1 plus 1/4, 2, and then 9/4. Alright, good. Center is 1 comma negative 1/2. Radius is square root of this. So it's better to complete a square. But if you find completing this kind of square too difficult, then you can go back and use this formula method. Nobody will care about all this derivation of this formula. H is negative a over 2, that was easy. Negative 2 over negative 2, so positive 1, yeah, we're positive 1. K is negative b over 2, positive 1 over negative 2, so negative 1/2, you got that? And r squared is this. And then taking the square root, you're going to get the radius. Finding all intercepts of this problem, plug in x equal to 0 to find y, plug in y equal to 0 to find x. I'll leave that to you. This completes section 4.